Hello, my name is Adam Getty, and welcome to my tutorial on how to solve a basic two-resource optimization problem in Excel. This tutorial is meant for students who are just starting an optimization class, or people wondering how to optimally distribute limited resources to maximize a desirable outcome. For starters, completing one of these problems will require the Excel Solver add-in, which you can download by clicking on the Add-ins tab, selecting Get Add-ins, then entering Solver into the search bar. It should be the first result. Once you have added Solver to Excel, you need a basic problem to solve. For two-resource optimization problems, they generally involve attempting to maximize an outcome by most effectively using two resources. Here's an example of what a two-resource optimization problem may look like. The Beaver Creek Potter Company produces bowls and mugs, which they sell at a profit of $40 and $50 respectively. These products require two resources to make, being pounds of clay and hours of labor. Each bowl requires 1 labor hour and 4 pounds of clay to produce, while each mug requires 2 hours of labor and 3 pounds of clay to produce. However, the company only has 40 total hours of labor and 120 total pounds of clay to produce these products daily. How should the company distribute these resources in order to maximize their daily profit? In order to start this problem, you must identify what your decision variables are, which are what you are deciding to use to maximize your outcome. In this situation, your decision variables are the quantity of bowls and mugs the company makes, since the bowls and mugs are what are producing the profit, which is the outcome the company is attempting to maximize. In this example, cells B2 and B3 will represent these variables. Next, you must create your objective function, which is an equation that represents how your desired outcome will be affected by changes in the quantities of your decision variables. In this problem, the desired outcome is maximum daily profit. So the objective function will reflect the total profit gain from selling each item, being 40 times the quantity of bowls produced, which is entered as 40 times B2, plus 50 times the quantity of mugs produced, so 50 times B3. Now that your objective function is set, the final step to preparing the problem for Solver is to quantify your resource constraints. In this problem, Beaver Creek Pottery Company needs two different resources to manufacture their products, being hours of labor and pounds of clay. The company only has a maximum of 40 hours of labor and 120 pounds of clay to produce their products, so these are the two limiting factors in the problem, which are commonly referred to as constraints. In order to quantify these constraints, we need to know the quantities of each resource used to produce each product and create equations that are less than the total availability of each resource. For example, each bowl takes 1 labor hour and each mug takes 2 labor hours to produce. So if we create an equation using the same logic for the objective function, we will get 1 times the quantity of bowls, which is B2, plus 2 times the quantity of mugs, B3, is less than or equal to the availability of 40 labor hours. Using this same logic, we can create another equation for the availability of clay, being 4 times the quantity of bowls produced plus 3 times the quantity of mugs produced is less than or equal to the total availability of 120 pounds of clay. Now that your objective function, constraints, and decision variables are created, you can now start importing them into Solver. Solver is located in the Data tab in the Analyze section. Once Solver is open, the first thing you must do is to set your objective, which we already did in cell B8 as our objective function. In this problem, we are seeking to maximize our objective, which is already set here, but in other problems you may want to minimize your objective or get your objective as close to a specific value as possible, which are options seen here. Next, you must import your variable cells, which we set as cells B2 and B3. You do this by clicking and dragging B2 and B3. Finally, you must import your constraints, which we did in cells B11 and B12. In order to do this, first click Add, then click your first constraint in the inequality, being for the labor hours, B11, is less than or equal to the availability, which is the constraining resource, which would be D11. Then click Add. Secondly, you must add the second constraint, which is the same process as the first. B12 is less than or equal to D12. Click Add. Finally, in this problem, since we are producing bowls and mugs, these products cannot be produced in partial measures. For instance, the company cannot produce half of a bowl. In order to represent this, we must set these quantities as integers, which you can do by clicking and dragging our decision variables, cells B2 and B3, and clicking this drop-down menu and clicking integer. With all of our constraints set, we can click OK and enter the final step, which is selecting the solving method. In this problem, the solving method would be simplex LP. With the objective set, the variables cells set, and all of the constraints set, you can now click Solve to find the answer to this problem. In this case, the total maximum profit that can be produced is $1,360 per day by producing 24 bowls and 8 mugs. Thank you for watching.